My name is Adela Muresan. I'm working at Banca Transilvania, which, for those who don't know, is Romania's biggest bank. We do have our internal IT department in Banca Transilvania and a separate IT department as well, part of Banca Transilvania. I'm managing the artificial intelligence department with two teams, the machine learning and the chatbot teams currently. And today we are going to speak about object detection, and more specifically we are going to use YOLO v7 to do this. So it's going to be a fast walk forward track to doing object detection, from learning to actual implementation and putting it to test, because, well, that's why you do it, to use it. And let me start by asking you a few questions. How many of you have some basic Python knowledge? That's good. Those who didn't raise their hands, well, the code is Python-based, but it's pretty simple, so you'll get to the idea. I was trying to do the setup as easy as possible, so I was thinking to use Colab. How many of you have used Colab before? Okay. How many of you have a Google account and willing to use Colab? Okay, good. So you can do your own setup on your machine. If you prefer to do that, it's fine. So we're going to do whatever works for you. And let's get started. How many of you have Git installed? Or at least you can clone a repository, you can download it or something. Because I put all the resources on a GitHub page. So I assume that you can see my screen. Yes. If you go to this GitHub repository, this is some helper for this section. And I'm going to click on this, so we'll go through it together. Okay. So if you go and clone this repository, and then we'll go step by step into it. The URL. Let's see. Once you clone this, I'm going to tell you a little bit what we're going to do today. So we'll have a brief introduction about object detection. We are not going to do segmentation today because we want to make sure that we are able to do some labeling and training a model and using the model in 2 hours, besides all the theoretical part. So then object detection is going to be easier. We are going to use YOLO v7 to do this. Python behind, it's going to be PyTorch behind YOLO v7. And I think we can do quite a lot of stuff. Fast forward track on this. We are actually using, if you're curious, we are actually, yes, we are using in production. We do have some identification modules that we have built inside our team. And one part of this identification module where we validate the user that's in front of camera, we validate its liveness. That's a separate topic with a classifier. And one part is a check of the lack of absence of a device. So you don't put your phone or your laptop or your TV in front of the camera. So if we detect any edge or a picture, then we just reject the video. We don't process it at all. So it's a fast validation to make sure that we start our liveness processing further on. We are using it. So once you've cloned it, you will see inside this resources folder. And here you will see a notebook. and I'm gonna use Colab for this. It's the notebook that I've exported from Colab. But if you want, we can go through the Colab notebook, and you can do the same steps on your laptops as well. So if you have a Python, you can create a virtual environment, do everything locally, install the requirements and everything, or you can start a Colab and then do all the work in Colab, whatever you prefer. So let me know when you started, and let's see if you can see the notebook. And the summary of what we're gonna do. So we'll do the setup, mounting the Google Drive so that we can have some storage where we can use. We'll do the setup, everything that we need for the project. And then we're gonna start talking a little bit about YOLO. We're gonna start with an example, and then we're gonna see some more details about it. Let me see if I can make it bigger somehow. Not sure how. Okay. Okay. No. Where is it? Okay. I don't know how to get rid of this stuff. Okay. Can you see my screen? Everything is written, or a little bit higher? Okay. Can you please raise your hands when you manage to set up the notebook? Okay, then we'll wait a few more minutes. And meanwhile, I'll continue with our summary, which was it of this one. Oh, this one, yes. Okay, so what we are gonna do, once we have the setup, we are gonna talk about YOLO. YOLO V7 already has a built-in model that you can use out of the box. So you can detect the classes that it comes with it. You have around 80 classes, so you have a person, you have a tie, you have a ball, you have all kinds of classes that you can detect. But sometimes you don't use these classes. Like in our case, we used our model to detect corners of devices and parts of laptops and the play bar. If you have a play bar, so things that are more specific, so then you'll have to train your own model. You can train from scratch, but then it means that you do need a big network to be able to do it and a lot of data. Or you can train your model starting from an existing model, which is what we are going to do today. So we are going to use the base of YOLO V7, and then we're going to build on top of that. You can use transfer learning as well, or with or without transfer learning. And we are going to do it from scratch. We are going to gather data. We are going to label it. We are going to train a model. We are going to test the model. And we are going to do the testing on the image, just to visualize it quick. Then, if you have a video, we want to make sure that you can run this model to make sure that your predictions are okay. So that we are going to use it on a video. And we are going to test it on webcam. We have two options, the Colab option, which has a little of a lag because we are sending data and it's a JavaScript behind. Or I also have in my GitHub repository, the Python code that you can do it locally to interact directly with your webcam. So both of these we're gonna do. I'll go step by step, and at each step I make sure that you are able to do it. If you need any help, just let me know and I'll come to your laptop and then we'll get what we are gonna do. So for those who didn't work with Colab before, what you are doing, you have colab.research.google.com, and then you can add a new notebook from there. And you can also import the notebook that we have here. You also need Google Drive, because we are going to mount Google Drive it's going to work as a disk for what we are going to do. And basically, we can interact with the Google Drive and put file there. So we see it in here. As you can see, I can browse through my drive from here. And we are going to put data in the drive. We are going to download data there. So we're going to use that. If you don't have Google Drive, so you prefer not to use it, just follow these steps. Just we'll skip the first step of using this, and we're going to do all the other steps on our local computers. Yeah. It's not under Neutralytics account. It's a different account, but it's official one. Yes. I know that the link, the GitHub is some Chinese name or something. It's funny looking, but it's the official one. Yes, I had the same question. No, they don't discontinue it, just building it with a twist. You can also have, like, it's faster, prediction time, accuracy-wise is way better. So just to give you an idea, we've started from YOLO v3, YOLO v5, YOLO v7 now, and we had more than double our predictions with YOLO v7 compared to YOLO v5. We've used the medium model, not the extra large one, the medium one, so the default one. And in terms of running time, around 75% of the times that we had before for the prediction. So it was way faster. And reconnect. And you also have the option to do image segmentation. It has a separate branch to do image segmentation, so not object detection. I'm not sure if everybody is aware of the difference about object detection and segmentation. So for those who don't know, you do the segmentation. So when let's say you have this microphone here, the segmentation is going to follow the exact geometry of the Microsoft, and the detection is going to have a bounding box around it. So just a plain bounding box. Even if it's going to be tilted, you still have one bounding box, a rectangle. Hence, while for the segmentation, you have the exact geometry and the exact shape. It also has pose estimation built in, so it has some different flavors that you can use for YOLO v7, but today we're going to focus on object detection because it's going to be the fastest one. So if you manage to set up the project, we can kickstart our steps. Please raise your hands if you need more time. Okay. Then what we're gonna do, we're gonna go step by step into it. I kept putting button. Okay. Yes, I managed to get out of it. So what you're gonna do, we are gonna start with the setup. First thing, we are gonna mount our Google Drive. So this is the command to mount your Google Drive. You just put here any location that you wish, as you see fit. I put content drive. And this is gonna mount your Google Drive. And if you go here, you have this folder. And if you go drive, you're gonna see content drive, my drive. And this is gonna be everything what you're gonna have in your drive, and you can interact with it. In order to set up YOLO v7 repository, what we're gonna do, we are gonna go in that directory. So you mimic the interaction with disk. So you can use Unix commands as you would do on any Unix machine, and you just run the commands here using this percentage bash. And then you can use all the commands that you would use on a regular Mac or Linux machine. So we do a change directory into our drive, where I've created a folder, presentation, and a subfolder codex 2022 inside this presentation folder. And then I'm gonna go in there because I wanted to put everything in one place, not to mix with the other things that I have in my drive. And then the next step is to clone your YOLO v7. This is the official YOLO v7 repository. I know it looks funny, but that's it is. And we are gonna go inside and install all the requirements. So if you run this step, I already have the requirements, but you should see your requirements being installed and your repository cloned. Is any of you who prefers to do it locally, or you're gonna use Colab? Okay. Please raise your hand when you are able to clone the repository and install the requirements, so that I know. Okay, we'll wait a little bit more. We'll do it step by step. This is the part that takes a little bit longer to do the setup, but afterwards it's gonna be an easy ride. If any given point you have an error or something, just let me know and I'll come have a look. Okay. You managed to install the requirements? Please raise your hands if you did so. Okay. We'll still wait a little bit more. Okay. I think we can proceed if the majority has finished. Or if you need more time, just let me know. Okay. So then we are going to the next step. As I mentioned, we are going to use YOLO V7, the basic model. The medium model, so YOLO V7 has several models. It has a small one, an extra large one, so it has different layers. So it works with different image sizes and so on. So we're going to use like the middle one out of all of them. And also we're going to use the one that has better prediction times because we want it to run faster as we are aiming for real time. And we are going to do two things. We are going to test the bare model, and then we are going to build our own model. But for both of these cases, we are going to use the model, and we are going to put it into our local, let's say local, it's going to be drive, directory. And in order to do this, we are going to do a directory called weights in our YOLO V7 folder. So if we are going to do here, this is something that you should see by now. You should have a Codex 2022 folder with a YOLO V7 folder inside in it. So what we are going to do next, we are going to create this weights folder where we are going to put the models. I have a pre-built model and also the models that I've downloaded, YOLO v7.pt. This is what we're going to do now. So we are making this weights folder, and we are doing a wget from this repository. So if you're going to go here in the repository, you'll see yes, that you have here different models, and you'll see the performance. And this is the model that we are using, the YOLO V7 with 640 image size, and I like the running time for that. And it's the link to this one, download B01, YOLO V7 PT. And you're getting this model to your local system. If you run this, you should get your model. I already have it, but you should see something like this, download it. And just as before, please raise your hands when you are able to do this step, or if you need more time, raise 2 hands so that I know. Okay, I don't see two hands anywhere. So we are going to go to the code part. Just the plain imports. We are going to use, as you can see, we'll use torch, numpy, some random, some utility things. They are, oh, I think I've skipped to a part. Some utility things that you'll see from the model that we have, and we are going to use that. We are going to set up that path, YOLO v7, as our current running path to be able to do this. So we run the import. Everything was importing, and now we'll get to the YOLO inference. In order to do any inference, we need several steps. We'll need to load the model. First thing, we need the model. Then we have a function to predict some data, to do processing on the data. But you don't work with the raw image as it is, you work with the processed image. So we have these three main building blocks that you build whatever you do. So it's the same code, whether you do it your own model, the custom one, the built-in one, you still have to have this part. So what we're going to do, we are going to have this process model, process image. One mention, if you are going to build, you are going to play with YOLO, you'll see here in the official repository that it has a train, a test, and a detect py. So these are the classes. This is the module to start the train. You can use this detect.py if you want to do a detection on a video or an image or everything, but it has a lot of options and it's a little bit confusing to go with. So that's why we have a separate one, a smaller one. But you can play with this one as well. It also has a webcam option, but it depending on the URL that you are using. So you have this one. Part of this code, you already find it here, but I stripped out just the bare necessity what we have. So we are going to do a pattern resize. We'll have an image size because we can't work with models with different image sizes. And that's why we need each image size as a parameter. And this device is going to indicate us later on. You'll see we'll use the device, whether it's a CPU or if we are using GPU, which GPUs to use. And we do some transformations. We do the conversions from BGR to RGB, and then we process it as an array. And in case if it's not a CPU, we use a smaller model. Minor note, YOLO v7 is really memory intensive. So you may have some memory problems. That's why you'll see this one, especially on GPU. It has a problem because it can go high, and it will. And that's why we are using a smaller module. And then we do the transformation, and we have the processed image. Once we have the processed image, we are able to go further with this. We can start with this method, predict on image. You'll see that it's going to get some options that we are defining. It's actually a dictionary of the different configurations that we use, and you'll see it further below. So first part is we will select the device. It's like the running processor that we use. One mention. I'm not sure if you know, in Colab, in runtime, you have here change your runtime type, and you can select GPU as well. I think by default is CPU, I'm not sure. And if you select GPU, it's gonna run way faster. Don't worry if it's gonna restart your environment. You can do it from scratch, and it's gonna be way faster to do it on GPU. Okay. So in order to predict something on an image, to do the detections, what we are going to do before, we are going to have the configuration in order. So one option that we need to specify is a device, because that's very important if we're going to run on CPU or GPU or not. As I mentioned, we are going to use the smaller model because of the memory issues. And another very, very important configuration is the image size, because you train your model with an image size and you have to predict with the exact image size. And this being a generic method, you have to specify it. And then we use this process image that we've seen before to process the image. What we have next, we have the names of our labels are built in our model, so we use that. And what we wanted to have here is to have different colorings for the boundary boxes where we do the predictions for the different classes. So if we have 3 labels, then model.names length is going to be 3. So we'll have, no, that's a bad example because still have 3. If we have 5 classes, then we'll have 5 names. And for each of the 5 names, we're just going to pick a random value for RGB from 0 to 255 in order to do the different coloring of the classes. Circling back to the memorization, if you are building the gradient where you're running it, you may really fast get to memory performance issues. So we are not building the gradient here. And then using our model that we loaded, we are going to do the prediction. And let's see the load model. The load is pretty simple. So in order to load the model, we just have a select device to read the configuration. And then we use this attempt load function, which is a function built in YOLO, which actually checks for this file that you specify on your local disk, or if you're not having it, it's going to check on GitHub and it will try to download it. And you specify the device. So let's run these codes as well. Okay. So now that we have the model, we have the predictions. We get the maximum predictions. We go, because on an image you can have several classes detected, so you predict all the classes. We scale the coordinates to be able to display them correctly. And in a reverse order from top down, we have the label index. So it's actually the class that's predicted because we are going to work with integer classes. And then you have a mapping from the label index to the label name. So we have this label name here. This is a text that we are going to use to display. So we'll just display the label that is predicted and the confidence that we had. And this plot one box, it's built in YOLO, and it actually is using the coordinates that we have here. We have the confidence and the class. It's using the coordinates to write on this output that we specified on a parameter here. So this is the input image and this is the output image. It's going to write on this output. It's going to write, as in it's going to write the label and it's going to display the boundary box using these colors that we specified with this line thickness. So what this method is going to do is going to plot the rectangle of the detection on the image that we have. And this is just the code. If we go further, we'll see the options that we mentioned. So we have here the options, the weights, that's actually the model path that we have. We've downloaded the YOLO v7.pt model in the previous step, and it's put here in this folder, weight. The image size is 640 because if we go here, this is the image size. We do have a confidence threshold that we don't want prediction lower than this confidence. Intersection of a unit threshold, we are going to see later on what we are going to use it. Device 0, that's the first GPU. Class is none, meaning I don't want to filter out any class. So if you have 80 classes, maybe you don't want to detect all of them, you want to discard some, so you have an array of classes that you don't want here. This is just defining the classes. And here in the input image, it's already built in. So the folder that you downloaded with YOLO comes with this inference folder that has images folder inside. And if you are going to have a look at this, you have this image too. Image here, you should have it because it's already included in the repository. And we are going to use it to test it. And you'll see that it's pretty easy to do it. So what we are going to do, we are going to read the image using OpenCV. And as I mentioned before, we are going to load the model. We don't load the model on the part that does the prediction because loading the model takes quite some time. So if you do it on a video or a stream, loading it each time, it's going to be very painful. So you basically load it once and then use it later. And we call this function predicting on image using these options that we've defined above, the model that we've just loaded, and we load the model specifying the path to the model here in the weights, the image that we want to process, so it's the OpenCV image, and the output image that we want to write on, so I'm going to just write on the same image. And I have an image show below to see the image. So if you're going to run this, you'll see as it's the wheel spinning, this is the part like loading the model. You see here the green arrow. This is the line where it is. And it's loading the model. It takes a couple of seconds to load the model. But afterwards, the prediction, it's fast. So you should see something like this. Let me just make it a little bit smaller so you can see my full screen. You should get to something like this. So congrats, you just had your first object detection predictions. You predicted on an image, and as I mentioned, the model has some classes built into it. So you have the person class and the sports ball class that the model knows about detected here in this image. Please raise your hands when you have the predictions. I'm guessing you have the person and the ball, right? Good. Now, we'll get to the fun part. That's why we are here to discuss about custom object detection. Because, yes, it's useful to detect cats and dogs and balls and persons, but sometimes you need to detect something else, like more specific to yours. So in order to do object detection, you'll have to do the same steps, whatever you want to do. You need the data gathering, which can be really painful, the train, and the test part. So for the data gathering part, let me make it bigger so that you can see what it's written. So for the data gathering, you can use existing data sets if you find one, or you can build your own. In some cases, you'll do both. So you may find a lot of open data sets available online that you can use for your purposes. Just Google your class that you want to predict data set, and you'll find quite a few on different sites. So it doesn't even worth mentioning. So you'll see in the collab here a link to a data set with credit cards. So don't worry, it's not real credit cards. It's like fake data. Oh, it's write your name here, el person, and things like that for the name and the digit. But they do look very real, and we want to use that. And I've also prepared some label data in the GitHub that you mentioned. So let me see. In the GitHub here, in the resources folder, you'll find a folder called train. And here, you'll see images and labels. You can clone it locally. It's easier to just work with it locally and then upload it once you have the train data. And we are going to do some training, some labeling as well. For the labeling part, so there are two options. One thing, we have this label data that we are going to use. It's labeled. Regardless of the labeling tool that you will use, you will still get to the same format. But sometimes you don't have this data given to you, so then you have to make your own. So one thing that we can do is gather data from a video. And you have a video, and you have different frames in the video, and you get the different frames from the video, and you use that for labeling if you want to label on the whole frame, or if you want something more specific, like in our example, we have a part where we need to detect the ID card because the user is asked to show the ID card, and we don't want to focus on the whole image because we want to focus just on the ID card, and because we are going to do the automatic rotation to 0 degrees. And in order to do this, we need the text on the ID card, and we don't want to discard the background. So what we did on this case, we had different videos we filmed ourselves, showing our IDs in different angles and the cameras, and we have a processing type where we did have an object detection for the ID card, and we just wanted to add more data to it, and then we captured this area from the ID card, and we used that later on. And in order to do the data gathering from a video, this is an example. We can do it, but I'm going to show you what we are going to use for the labeling, and depending how much time we'll have, we'll generate new data. So I'm going to ask you to just film yourself showing an ID, sorry, not an ID, a card to the camera, but depends on the time. So in order to understand the code that we have here, let's go through it briefly. So we have these straight images from videos. If you have a folder with the different videos, like I do, I have here different videos where I'm showing to the camera my ID card. It's something like this. And I display it on the different angles. And I use today this later on to generate the different images that I'm training on. And you see here like some images with the cards. You won't find my real card in the training data in the GitHub. So that's why I wanted to give you this to be able to generate more data, because we do have like a small model. We'll build together a small model, but in order to have like a really performing one, you'll need to add more data, and you'll have all the tools to generate what you need. So we have here this method to extract images from videos. If you have a folder of the full videos, that is just going through the files. It's reading the file, and it's extracting the frames from a video. And in order to do the video processing, we use this video capture that's built in OpenCV. You just specify the path to the video, and then you'll get the video information. It's actually, I called it video, but it's more like a video capture object. Using the OpenCV attributes, you can have some properties about the frames, the frame per second, if you need it. But in this case, I'm just using the number of frames just for display purposes later on. And iterating through the frames is quite simple. You just go in and iterate in the number of frames. Or you either have a generator, or you iterate and you read video.read one by one. From here, sometimes you don't need all the frames, because if you are filming like 25 frames per second, how many moves can you have in 1 second? And that's why you're going to skip some of the frames. So I've included this skip step. So we are just going to read from end to end frames. And if I have a frame returned OK, I'm going to have an output file name. So it's actually the output path that I specified, where I want to save my images, and the file name that I have. And it's going to be a GPP, and the index. Oh, and here the file name I didn't mention is actually the name of the video. It's splitting by the separating and taking the last element of the path. So basically the video name. And I'm writing the image to the disk. So if you see here, once I run this, I have a video called video 3. And I'm writing the video here in data train images from 2 to 3 with a skip step. I haven't included any real video in the data, but if you want, we'll get to this part as well. And then we are saving the video, and you'll see it's writing here the data where it's saved from each of the videos, like this kind of images. Okay. Now, labeling. I was thinking what labeling tool to use, because there are quite a few options. I've decided to go with label img, or this is how I call it. I'm not sure about how you pronounce it. Actually, label img is what's the base for Label Studio now. But for Label Studio, you need to have an account, and they don't want to make you create accounts just for a tutorial. Label Me as well, computer vision annotation tool, label box, and several others, cloud-based systems, local system, premium, whatever. There are different options. Some have more features, especially for the object segmentations. Some of the tools really help you. They have an automatic way to follow contours, and then you just tweak the contours as you may see fit. But as we are just going with object detection, label img is sufficient. It's pretty easy to install. So if you have Python, then you'll have pip, and then you can use pip3 install label img. What this command is gonna do is gonna install labeling in your local computer, and I encourage you to do so if you have Python, and then just get your hands dirty, as they say, and just do some labeling. There are any other options to install label.mg. You can have the zip file and everything. So if you have no, label.mg, you see here the details and how to install it. It's gonna look like this. So we'll create the bounding boxes around the different objects, and then we'll define our classes. Or if you already have some existing classes, then you can use your predefined classes file to work with that. And you label the data. You have the different options to install it. The easiest is with pip. I've included in some images that you can play with. So if you have a look here in your folder, where is it? Resources. Not here, sorry. Here with the resources in train, you have some images. Just so you know, I also have the labels for that. So you don't have to do it now if you don't want to, but I encourage you to try a couple of examples. And let's see how it's going to look like. I'll put back to the install. Here, bigger. You can work with your mouse to do everything and then select the images, but I've also included the shortcuts, which I found to be very useful when you have to label quite a lot of data. Just go from one to the other. Yes, let me make it bigger. Oh, you don't see the name. I'll put it here, and then you'll see it. I can make it bigger. Just as with other machine learning projects, like building the machine learning module is just one teeny little piece, gathering the data, data curation, doing all the deployment and everything. It's a whole different picture. So if you look at machine learning getting to production pipeline, as you see all the different steps, different sizes, like the machine learning model is going to be like this, and putting it to production is going to be like this, because you have a lot of time spent on the data, then you're going to build your model, you see that you don't have enough data, or you have problems with different classes, and then you relabel the different options. You can also just not label some data. This is to handle background images, as it's called, for object detection. If you want to train the model to understand that that picture is not something that he should learn from, so you don't have the class in that picture that you can use that for this, but it depends on the tools the models that you build later on. So, I'm not sure if you managed to install labeling. I'm gonna show you some example how we are gonna do the labeling. As you already have the data, so to label all the data needed for the model is gonna take way more than 2 hours. But we're gonna go through several examples, and you can try on a couple of images, and then we can go later on. And in the end, if we have time, we'll just generate videos, and then we'll build the models and everything. So once you have labeling installed, it's pretty easy. You just either start it from anywhere, or you go to the directory where you have the data. I have here in images, they're already split for train and val. But in the beginning, you'll just have some images, and then you'll decide later on how you want to split the train, the validation, and the test set. For YOLO v7, the test folder is optional. So to speed up the process, I've just created this train and val, but you should definitely have train, test, and val folders. So if I go into my folder, let me make it bigger.